Welcome everyone. So we will be discussing Indian contribution to science. This is a book which is compiled by Vigyan Bharati, and this is one of the chapters which is there for the VVM examination. Chapter 12: Science and its various branches. Human beings differ from other animals in many ways. Of particular importance is the ability to think, communicate, and use language. This in turn gives us the skill to pass on information from one generation to the next. This ability has been more and less responsible for the growth of the systematic analysis of different questions. Systematic analysis of any question can be called science. Science is no way limited to laboratories or classroom. What your mother does as a part of a cooking process in her kitchen, skills that have been honed over years of experimentation and careful observation, is not far more from a scientist's experiment in a lab. Once any query is analyzed in a particular or rational modus operandi, it is obvious to gather some views and answers. Next comes the second litmus test for science. Result must be repeatable and reproducible. What one person does in the lab in India, she or he should be able to get the same result multiple times by someone else in the lab located in a different country. For instance, Japan should also get the same result using the same input and instruments. It is easy at times to think that what appears in scientific writing are the author's personal views. However, when something is actually circulated as a part of a larger body of scientific knowledge in reputed scientific publications, it has been cross checked by multiple independent researchers and rational thought process of all related scholars agrees with those facts. This ensures that false science and erroneous claims cannot be sustained for any considerable duration. The person who invented the wheel, the person who discovered fire, the tribes that discovered agriculture, they were all scientists in their own right. From the times of the early Greeks till the times of Galileo and Newton, those whom we in present days refer to as scientists were actually philosophers or naturalists. Archimedes was a philosopher, as was Galileo. Even Darwin was a naturalist. A more stringent categorization of science into branches came about with the growth of scientific knowledge. People like Archimedes, Aristotle contributed to all branches of human knowledge without bothering about division of physics, chemistry, or biology. This trend can also be seen among philosophers like Galileo, Leonardo da Vinci, John Kepler, and Newton. They also did not have a fixed area or branch of study. They analyzed nature as they observed it and tried to come up with suitable explanations. Sometimes, when they felt the need of the extent of range of human senses, they also invented devices like telescope or a microscope. In those times, you would also find a person like Benjamin Franklin, who was a politician and diplomat but was skilled observer of the nature. He proved that lightning was a manifestation of electric discharge and also invented bifocal lens. Science and mathematics have always been closely interrelated. Mathematics enjoys the undisputed position of being the universal language of science, irrespective of your branch of interest. Many a times in history, it becomes difficult to classify people as just scientists or mathematicians. Newton himself is equally famous as both, though his philosophy, Naturalis Principia Mathematica, often referred to as simply the Principia, would primarily be considered as a mathematical text. One comes across names like Gauss, Euler, Bernoulli, Pascal, people who made breakthroughs in mathematics and then applied them in the natural sciences to further our understanding of the natural world. As the body of scientific knowledge increased and the study of science became part of university curriculums, it was found that for one person to be able to assimilate and work on such variety of topics would be impossible. So people needed to specialize and develop topics of study such as physics, life science, chemistry, and so on. In the past, we had people like Faraday who made excellent contributions to physics and chemistry. His two major contributions being law of electromagnetism and law of electrolysis. We also have Louis Pasteur, who graduated with honors in physics and mathematics but worked mainly in the field of chemistry, and alongside discovered that most diseases are caused by microscopic germs. Later, life science branched out into botany and zoology, studying plants and animals respectively. Eventually, those studying chemistry took leave of their colleagues pursuing two. Broad divisions of science emerged on the basis of their subject matters, with chemistry forming a kind of feeble bond between all the three. With time, more specialized topics arose like organic chemistry, astrophysics, paleobotany, that is, study of fossil plants. With increasing understanding and knowledge, the degree of specialization has also increased and has grown narrower every day. To paraphrase what the famous science fiction writer Isaac Asimov once said, as we increase our knowledge of the world we live in, people will be more and more specialized in their chosen topics, and the only people to know something about all the branches of science would be science fiction writers. In recent years, however, the deeper understanding, the inherent connections between different branches has been increasingly felt. The subject matters are still too vast for one person to be able to work on two different fields of knowledge. But the growing feelings is that to be able to better answer the questions about nature that still baffle us, or to be able to face the new challenges, greater coordinations and sharing of knowledge in there is required amongst experts from various fields. For example, considering MRI machine in a hospital to ensure that the machine works and can be used for diagnosis, a coordinated effort by mathematicians, physicists, engineers, software programmers, and doctors is needed to take place. Works of different domains of science are starting to intersect more and more, and some of the best research is being carried out by interdisciplinary endeavors. Some interesting examples are at the intersection of two or more disciplines are bioinformatics, biomechanics, quantum computing, and molecular biology. Some of the areas of concern that multidisciplinary research include global warming, sustainable development, and land management and disaster relief. Another important fraction and differentiation exists among scientists in terms of how they work in the respective fields. There are theoretical researchers who study problems, try to hypothesize solution, and attempt to model the problem as well as solution using mathematics. Then we have experimentalists who design a setup and conduct experiments either to verify a hypothesis made by the theoreticians or to learn more about the system being studied. A newly emergent approach due to massive increase in the use of computers is the computational approach, where one may stimulate a system on a computer and try to resolve its equation or stimulate certain experiments being performed on a system. An interesting differentiation of the disciplines occurs quite naturally from their scale of studies. We have scientists who study their things as big as galaxies to scientists studying subatomic particles. In between these two extremes, you can imagine a whole range of sizes where the interests of different scientists lie. You could have a biologist dealing with normal living organisms, the ones we see in our everyday lives. Then you might have a microbiologist studying microorganisms or molecular biologist studying the fundamental molecules that sustain and propagate life. The diversity is ever increasing. Thank you.